Hey, trick class, we're going to look at this problem from the 7.8 homework set where we're graphing the tangent function. And the first question that it asks when we're graphing the tangent function is, what is the amplitude of, if one exists, okay, if one exists. And if you look, the choices here is amplitude is and amplitude does not exist. And you were used to, like with sine and cosine, just grab this number in front of tangent or cotangent, or sorry, sine or cosine, and that was amplitude. Just drop the negative sign if it happened to be a negative. Well, that doesn't work with tangent because, if this, again, this had been sine or cosine. This is the tangent. It's the distance from the midline, which is at 0 here, up to the max, which is at 2. So the midline would have been, the amplitude would have been 2, which is that number. Right? But with tangent, you don't have a place where it peaks and then bends and starts going back down. You don't have anything like that. Tangents just go off to infinity. So we don't have an amplitude. That's not what we refer to when we're talking about a tangent function. So the amplitude doesn't exist here because this is not a sine or a cosine function. All right, now we can't talk about the period of a tangent function. So when we did the period for sine and cosine, we took 2 pi and we divided by the number that's being multiplied by x. Well, the same thing we're going to do for tangent, except instead of 2 pi, we're going to have pi. All right, so pi divided by this number in front of x would be pi over 4. So that's going to be our period. All right, so pi over 4, there's our period, and then it wants to know what's the phase shift. So the phase shift is basically setting this thing in the parentheses, not the whole thing, but the stuff in the parentheses, equal to 0, and then solving for x. So add the pi over, you'd get 4x equals pi. Divide both sides by 4, and you'd have x equals pi over 4. So that is our phase shift, and because it's positive, we're moving to the right. Okay, so the phase shift is pi over 4, the period is pi over 4. What that basically means is it's going to look just like 2 tangent x if we didn't shift anything over. Now this is where Desmos will come in handy. There's our graph, okay? You can see the numbers that they have down here. These are the vertical asymptotes that they have in the pink color. You can see -4, +4, the numbers that they're graphing for the y coordinates. So I'm going to go ahead and change my window, my y's, to have a -4 on the bottom, a +4 on the top. And I'll go up by 2s. Nope, go up by 1s. Looks like they have 4 tick marks in between. So there's that. And then this is the y-axis. This is pi over 2 there. That looks to be kind of the range that they're going left or right. Well, this is 5 pi over 8. Let's just use the bigger of those two. 5 pi over 8, slightly bigger. And then I'm also making my step size be pi over 8 because that's what would display pi over 8, 3 pi over 8, pi over 4 is 2 pi over 8, 5 pi over 8. So I'm making this step size be pi over 8, and that'll make it easy to see where those asymptotes are. So there's the graph. I can zoom out a little bit here. You can see there's one at pi over 8. There's an asymptote at 3 pi over 8, 5 pi over 8. So there's asymptotes at pi over 8, 3 pi over 8, 5 pi over 8. There it is also. The big difference is we're rising in between the asymptotes versus falling. And you can see with our graphs we are rising in between a set of asymptotes. So that means that this is going to be my choice, which is D on mine. All right, so Desmos really can help. That was the end of that question. There's no domain or range questions. It's just basically getting the graph from the choices that you see here. So Desmos would help tremendously with that last one.